Good afternoon. Good afternoon. Are you there? Can you hear me?
Yes, I can.
What about the others? Why are you so quiet? Aduma Tevin, can you hear me?
Good afternoon.
Good afternoon. Cyril Ayubi, are you there? Alemi, Cyril Ayubi, are you there?
Yes, I'm here.
Okay, I know it's after lunch and you don't really want to talk, so I don't know how you do it. Sigei, are you there?
Yes, I'm here.
Okay. All right, I want to believe that most of you here were in the morning class. And for that reason, I want us to look at these two questions here. They're not really questions. Actually, it's a summary. It's really, I want it to look like a summary of what, in fact, let me first, I have a problem here. I have a problem here. I'm not able to present. That's going to be a disaster. I don't know what has happened in the interim. I'm not sure what happened over lunch hour, but I seem to be having a problem of projecting. Let me try again. I don't know if it will work. Okay. Please tell me if you can see what I'm projecting. Can you?
Yes, I can.
Okay. So I just want to bring to your attention, this was the first set of slides that we looked at. And at the end, that is after that, at the end, I've tried to create some questions there which should really help you to understand what was that topic all about. So, for example, why is circuit switching not ideal for computer-to-computer communication? I think we've covered that. What makes packet switching better suited for computer-to-computer communication? Remember that we are in a programming environment. So obviously there will be one program trying to communicate with another program on a different computer. And underneath, you will either have circuit switching being used at the network level or packet switching being used. And so the idea of which one is better for computer communication is important. Anyway, there are those questions. And lastly, remember that I said there are many different wide area network protocols, especially the connection-oriented ones or the virtual circuit ones. So that is something for you to research on and find out just which ones are better. Okay, so those questions, I want you to look at them. I want you to look at them as we Let's see, move on. Now, I'm not sure really what's happening here. Something is really happening. We can find a solution to it. Trend. Okay, let me try and sign out and log in again. I'm not sure what happened, but something really happened. Jara Abdiaziz, I can see that you try to raise your hand. I'm not sure what you would like to say.
No, madam, it was a mistake.
It was a mistake. Okay. Mm. Okay, let me see if I can project this. Okay, so I want to similarly bring to your attention some questions that I have put at the end of this other topic, the one we did just before the break. And I would like to say that if you cannot answer these two questions, then probably you didn't understand what we talked about. Because I was trying to address these two questions. I was trying to say that the IP layer is a connectionless layer, and there are some reasons why it was developed that way. So the question here is, what arguments are provided for developing the IP layer as a connectionless service and not a connection-oriented service? What arguments did I give to you, or did I discuss with you? So I want you to think about it and just tell me. And then the second question is, discuss why the connectionless IP layer is not a good platform for developing network applications. Those are the two things I was trying to drive home in that session. So I want to be clear that we have understood it. So let's try and answer these questions, even just briefly. Anybody who has an answer for any one of those two questions, based on what we discussed in the morning? Anybody?
I can try to answer the first.
Okay.
I think that IP is implemented as connectionless rather than connection-oriented because the number of intermediate computers on the internet is vast, and the number of those intermediate nodes on the internet is very vast.
Mm-hmm.
So we cannot know how long it will take to establish a connection from one computer to another, and also that those messages for establishing and terminating the connection will also be too many, so they'll end up taking up unnecessary bandwidth.
Mm-hmm. Mm-hmm. So you're talking about bandwidth, huh? It will take a lot of bandwidth to, I mean, if we were to go the connection-oriented way, it would take a lot of bandwidth. What did you say about the intermediate nodes?
I said that, for instance, if you want to connect to a server that is, say, abroad, say in the US, you'll have to go through so many intermediate computers, and it would take up too much time to try to establish a connection from here all the way to that server.
Yeah. So it takes time. It takes time to establish a connection, and it also ends up taking up a lot of bandwidth. Anything else? Why we prefer the connectionless? So that means that, on the contrary, the connectionless does not take time. In fact, there is no establishment of connection. So you are therefore not going to use any time to establish a connection, neither will you take any bandwidth to establish a connection. And remember, when you're establishing a connection, you are not yet sending data. You're just using the network for establishing a connection. So all this time and bandwidth you're using to establish a connection, you could be using it for something else. That's the idea. So connectionless will not take time, neither will it take bandwidth in the establishment and termination of connection. But for the connection-oriented, you require time and bandwidth to establish and terminate the connection. Anything else?
I could try for the first question as well.
Yes, continue.
Another reason for using the connectionless service is because the internet is unreliable, as in some packets may be randomly dropped, and because so many messages are moving through the internet, packets may be randomly dropped by intermediate nodes. So maintaining a connection is difficult within the internet. That's another reason.
Maintaining a connection may be a little bit complicated. And I think, yeah, maybe let me add something to what you have said. The nodes, the likelihood that a node is down at any time on the internet is much higher, because remember, it contains billions of computers and network devices. So the likelihood of a node being down is very high. So the likelihood that your connection will always be up is very low. And remember, when you create a connection, you want to use that connection for the transfer of data. So if a connection is created through the nodes and one of the nodes goes down, remember, you don't have a connection. You have to start again, as we said. So the chances of your connection being interfered with by some problem on the internet is very high. And remember, you don't have control because some of these devices are not within your network. They are within other people's networks. So you really don't have control. Yeah, so I agree with you. I agree with you, Makoha. So let me take you back to your notes so that you don't forget what we said. I think it is somewhere in your notes where we talked about the unreliable characteristic of the IP we talked about the reliable aspects of the IP, but here is where the answer is really coming from. That there is a high cost to providing reliability. Remember, connection-oriented always means reliable. That one you should always remember. Connection-oriented always means reliable. So if you are to use the reliable one, there's a high cost. And that cost is in terms of time and bandwidth. And remember that when you are creating the connection and putting those entries in those tables, that also takes resources. So remember here it's talking about time, resources, and bandwidth. So it also takes up a lot of memory. So if you have 1,000 connections through a switch, then that switch has 1,000 entries in its virtual circuit table. So each connection takes up some memory within a device. If a connection is passing through it, it must have an entry in its table. So it not only takes time, it takes up computer resources to build those connections, and it takes up network bandwidth because you are passing packets that are not related to the data you are sending. They're just related to establishing and terminating connections. And then, of course, this one you need to have mentioned that not in any case, you may spend up all this time and resources and bandwidth trying to create this connection. And yet an application doesn't need it. There are some applications that don't need it. Because maybe you just want to send one message. Why spend so much time and resources and bandwidth to create a connection, and at the end of the day, you only send one message? It doesn't make sense. So there are some applications. I try to give you an example of a short email. Maybe, and I'm not saying you're attaching things to the email, because you may attach a video file and so on. Those are not what I'm talking about. Maybe you're just sending a simple message. Such an application might not need that reliability and all that effort. what's the other reason? And that other reason comes from the quality of service. So if you understood what I said, you should be able to still answer that question. It's still part of this question here. What arguments are provided for developing the IP layer as a connectionless service rather than a connection-oriented service? So it's still related. So if you understood what we said, you should be able to answer that question. Anybody who understood that issue of quality of service? Anybody? First of all, have you ever come across this term called quality of service? Have you come across that term, and what exactly does it mean?
Quality of service was, okay, the brief description was congestion control, how you control traffic going through any part of the network to ensure performance is maintained. A required performance, yeah.
A required performance. So the quality of service is really, what do you say? Yeah, just the quality of service, which has to do with performance. So you may get poor quality of service because the performance is so low. You may get a high quality of service because you are served very fast. So assume you go to the bank and you go in there and within 3 minutes you're out. You've done what you want and you're out. You will say, well, this guy has provided a good service. It's really the quality of service. Maybe another time you go to the bank, you take an hour and you start complaining, what kind of poor service are these people providing? You know, that's a quality of service you're complaining about. So quality of service has a lot to do with performance. Okay? Now, in a connection-oriented service, you can achieve quality of service. First of all, let me go back to the circuit switching. With circuit switching, you can provide quality of service. So for example, I want to create a connection between Nairobi and Mombasa to transfer video files. In the case of circuit switching, I can say, look, for me to transfer this video file, I need 10 megabits per second. I need a 10 megabits per second pipe or channel between Nairobi and Mombasa. So you request for that 10 megabits per second channel, you are given and you pay for it, whether you're using it or not using it, but at least you're guaranteed a quality of service because you know that 10 megabits per second is set aside for your transfer of video file and you are not sharing it with anyone. So it's very easy to provide the kind of quality of service you want when you have, when you're using circuit switching. Now, if you're using virtual circuits, it's also possible to achieve quality of service. How do you achieve it? Remember we said that when, remember we said here that when you are creating, when you're using a reliable channel, you need time, you need to set up computer resources. Now, what are those computer resources? You can set aside the memory that you'll be used for creating those entries and what are they called, connections. But you can also set aside the network bandwidth. You can determine that for this connection, we can give it 10% of this channel. And then you create another connection, you say we'll give it maybe 20% of that channel. Now, let me just throw it. So assume you're creating a connection and that connection is passing through these two intermediate nodes. These are intermediate nodes, right? We said you will have some memory attached to this where you put in those incoming port, incoming VCI, that table, that virtual circuit table, that will require resources. But with each of those entries, you can say, look, for me to send it out, I will use 10%, I will set aside 10% of this connection for transferring data on that channel. It's very easy to do that. It's not normally done, but if you need the quality of service, and of course you're willing to pay for it, that can be done. So that when your data comes into this device, you know that 10% of this channel bandwidth has been set aside for that connection. And so, of course, you'll have to do the same on this side because that there's a different entry, but for the same connection here. So you can say for this connection passing through here, we'll give it 10 megabits per second. And then another connection will be created. We'll say we'll give it another 10 megabits per second or less. So it's very easy to achieve that kind of quality of service provision with a connection-oriented service. With connectionless, there's no way to do that because there are no tables here to do with any connection. Nobody knows which packet is going to pass through this device. So it's not possible to set aside anything. But for connection-oriented, it is possible to provide quality of service. So we say, therefore, if the service quality features such as connections, error checking, and so on are required by an application, they can be provided. They can be provided. Of course, it will be provided. The application will be able to state what they want, and it can be provided for them. And since the quality of service is application dependent, then the argument here is that you don't necessarily need that quality of service for all applications. And so you don't need a connection-oriented network service to do it. Since not, remember I've said quality of service can easily be provided by a connection-oriented network service, as I've already explained. So the application above it can always request for the quality of service it wants. The transport layer will know what kind of quality of service it wants, but remember the transport layer to provide that service must use the network service. So the network service will set aside those resources to provide the quality of service that the application requires. Okay? Now, the issue here is that not all applications require some kind of quality of service to say, look, please put aside 10 megabits per second for my data passing through the network. Not all applications require that. Assume you're sending an email. Well, it will arrive when it arrives. Yeah, you know it will arrive. You don't have to say, I want my email to go at 10 megabits per second. You know it will arrive at some point. But there are some applications like video conferencing and so on. You want the data to arrive at a certain rate or within a certain time. So not all applications require the quality of service. So the argument is this: there is no need to ensure that you have a connection-oriented network service to provide that kind of quality because not all applications need it. So it's better to use a connectionless service and then provide the quality of service at the transport layer. That is the argument. Provide the quality of service at the transport layer rather than at the network layer, because not all applications that use the network layer require that kind of quality of service. So instead of implementing it in the network layer, why don't you implement it in the transport layer and just provide it for the applications that need it? That is the argument. I don't know whether that argument makes sense. Does it make sense? Or not? So assume this is the network layer. Assume this is the network layer. I have one computer here, and I have another computer here, and there are two applications that need to talk to each other. If this is the network layer, and we want to provide a quality of service, then it means that this thing here must be connection oriented, because you cannot provide quality of service with a connectionless network layer. You can only provide a quality of service with a connection-oriented network layer. But the argument is that not all applications need this quality of service. So why put it in the network layer in the first place? You don't need to put it here. So put it at the transport layer so that the transport layer can only do it for those applications that need it. Most of the other applications that use this network layer do not need that quality of service anyway. So just have a general network service that can be used by everybody, and then the quality can be provided for individual applications that need it at the transport layer. That is the argument. Does it make sense?
Yes.
Yes, no, yes, no, yes, no.
Is it like the internet phones, like the Cisco voice over internet?
Pardon?
Is it like the Cisco phones, the ones that we see at the offices? Do they use the internet protocol for phone calls?
Yes, they use the internet protocol. They use what we call IP, they use what do they call it? Something over IP.
Voice over IP.
Yes, voice over IP. And I'm not even sure that voice over IP, and remember, if it's voice over IP means it goes through the IP layer, or it is transported on the IP layer, which is connectionless. The IP layer is connectionless, and we are trying to ask ourselves, why was it made connectionless? And we are saying not all applications require the connection oriented. So one of the applications that you mentioned that requires connection oriented is voice over IP, but it's just one application out of the many applications that run on top of the internet. So you can't make the network connection oriented just to serve one application, like voice over IP. You can't do that. So you make the IP layer connectionless, and then you provide quality of service at the transport layer. So voice over IP would be done by some algorithms that are implemented within the transport layer, but specific for that application, or specific for applications that need that kind of real time. So I think there's another, what they call it, a real time transport. I think there's a different transport control protocol. It's referred to as, I think, real-time transport control protocol, something like that, which is meant for applications that require have real-time requirements. I don't know if I've answered your question.
Thank you.
Okay, maybe this argument that it doesn't make sense. Does it make sense to you? No, it's me who doesn't know how to explain it. Okay, but did you understand the first one? This one? This one, did you understand it? No? Even this one you didn't understand. Okay, then I think maybe I need to give you this as a homework. You go and think about it. I think we need to give you this question as a homework. You need to go and think about it and try to, and I don't want you to use those words that I've used in the notes. I want you to provide the reasons why the IP layer is implemented as connectionless and not connection oriented. Using those two arguments that I've talked about, one of the quality of service and one of the high cost of reliability. Maybe that will give you some time to think about it. Okay, so that will be one of your assignments. But let's try and discuss the second one. Discuss why connectionless IP layer is not a good platform for developing network applications. Why do we have another layer on top of the IP layer? So that on your computer, you will have the IP layer. You'll have the IP layer, but you'll also have the transport layer. In other words, why can't I just put my application and it runs on top of the IP layer? Why do I have to make my application run on top of the IP plus the transport layer? Where the transport you can have either have TCP or UDP. Why must it run on top of a transport layer and not the IP layer? That is the question. This is the norm. This is not the norm. Applications don't run on top of the IP layer. And the question is why? Why couldn't you just write your applications on top of the IP layer? And remember, the IP layer will take your data from computer A on network 1 to computer B on network X. So it will do the job. It will move data from one computer to another. So why can't you use it to write your applications when two applications on two different computer networks need to talk to each other? Why is IP not sufficient? And I think we discussed that as well. We also discussed that one. Do you remember? Yes.
May I try, please?
Okay, Marco.
I think it's because the IP layer is okay. Packets can arrive out of sequence. The IP layer has no flow control, meaning that packets will arrive out of sequence, and you need a way to maintain order within the packets that are arriving from the internet. So the transport layer acts as an in-between between the network layer and the application to implement flow control for the data that it is communicating with.
So does flow control deal with out of sequence issues? Because you might be mixing issues. What does flow control deal with?
Okay.
Remember, there's error control and flow control, yeah? So I think you're mixing issues.
I think I'm confusing them as well. I was thinking more of packets arriving out of order, and yeah, I think that is error control, whereas flow control is where it controls the rate of how fast data moves from arrives at a location and leaves that location.
Yes,
I'm confusing
yes,
the two.
you're right. Flow control has to do with not overwhelming the receiver, not sending data at a rate where the receiver can't receive them, correctly, or has the capacity to receive data at that speed. That is flow control. Error control assumes there are some errors that take place, which has to do with lost packets and packets that arrive which are already mangled in one way or another. Yeah, so having defined those, so then what point were you making? Why is connectionless IP not a good platform?
Because the IP layer does not implement error control, where packets might either be missing or arrive out of order. So the transport layer acts as an error control measure in place to allow the applications to work with complete data.
So if I took my application and run it on the IP layer, and the IP layer does not provide error control, it does not provide flow control, what would my application, what would be the end result for my application?
There will be okay. If, for example, it was a voice communication, there will be several starters and missing sections within the voice, within the audio that is received or sent over the internet, because the packets will be might be randomly lost, might arrive out of order, and if the application working on the IP layer receives those packets as they arrive at the IP layer, the order won't be guaranteed.
Yes. And yeah, I agree with you totally. And for applications, that is important. If you are sending a file from computer A to computer B, you don't want random sections of your file missing because the IP layer was not able to deliver all the packets that were sent. You've talked about voice. Maybe you're listening to an audio file and some sections of the audio file are missing because the IP is not able to do either flow control or error control. The users will not be happy. So the fact that the IP layer is connectionless is a fundamental thing that needs to be taken care of. Because if you don't take care of it, then you will run your applications on the IP layer. You will have applications that always send data, but it never gets to the destination. Only part of it gets to the destination. And they even get out of order. They even can be received out of order. So assume you're listening to an audio file, and you receive some sections of the audio file that were supposed to come later, coming before others. Would you even be able to make sense of that audio? Maybe not. A section that was supposed to come later comes earlier, and then another section that was supposed to come earlier is now much later. And imagine you trying to make sense of that audio. It doesn't make sense. And even if it's just a file or a web page, assume you're downloading a web page. Some sections of the web page that were supposed to be further down are now before, the information is kind of mixed up or out of order because different sections of the web page were carried in different packets and they arrived out of order. And IP doesn't know how to put them back in order. Remember that the IP layer doesn't have that facility for putting packets back in order. So it will just take them in the order they arrive, that out of sequence order, and give them to the application. So if your application is the web browser will display them in the order in which they arrive. So you can just imagine the mumble jumble on your screen. So I hope it is clear that the IP layer is not a good platform. And again, these things are somewhere in your notes. So let me just bring them to your attention again. Here, we talked about IP characteristics, but I mentioned that one of the important issues about the characteristics of IP layer is that it provides unreliable delivery, which we have said it doesn't provide retransmission for lost datagrams. There is no flow control. And without flow control, if packets arrive too fast for the receiver will drop them. They'll just get lost somewhere. So it will be a whole confusion And then the IP layer will just take what it receives and give to the application in the order in which it arrives, with some of them missing. It will just be confusion. And also notice that the IP layer does not send acknowledgement. Even for the ones it receives correctly, it will never tell the sender that I received packet 1 and packet 5 and packet 8 and packet 10. It doesn't even say that for the ones it receives. So the sender has no idea. Remember, I gave you an example in the morning. Assume you are using the IP layer to deposit money in your account. So you send a request and say, please deposit this money in account X. And it is 1 million Kenya shillings or maybe dollars, I don't know. But assume it is that amount you want to deposit. You send the request using the IP layer. Let us assume it arrives, but you don't get any acknowledgement. So you don't know, did it arrive? No. Did it deposit? No, you know nothing. Because it doesn't bother to acknowledge. But at least where it arrived, most likely it was deposited, because it will give it to the application and the application will add to your balance. So even if you don't get an acknowledgement, at least your balance has been updated. But what about the case where it didn't arrive and no message is sent back to the sender? So they might go away thinking, look, I deposited 1 million. You go back the next day, nothing. The message got lost. Nobody told you it got lost. And that's it. So it is just not a good platform. It's just not a good platform for developing applications. Right, so those are things we discussed in the morning. So in case you are not there, please read them. These are the things: dropped messages, reordered messages, duplicate messages, and arbitrarily long delays for messages. I think we explained those. Those are all issues to do with the IP layer and the service it provides. So it's not a good platform. So look at these questions and just know that that is what we are trying. We are trying to understand what kind of platform is good for application development. And we have established that the IP layer is not good because of the features that we have talked about. But this first part of the question is trying to address, but why? Whoever developed this IP layer to work like that? Why was it developed to work the way we are describing? And there are good reasons for it being developed that way. It is not by chance. It was developed to work that way, where it can drop messages, it can receive them out of order. That is how it was developed. And so we are trying to answer the question, but why was it developed that way? And again, I've told you that the answer to that question is in these two. One, the high cost of providing a reliable network layer. It's a very high cost, and not all applications need it. The quality of service is the same. Not all applications need that quality of service. So why develop it just for specific applications? Why not provide it elsewhere in the transport layer? Those are the arguments. So, but we have agreed that you will do this part A as an exercise. So please start thinking about it and provide your arguments in your own words, not in the words that are in your notes there. So any questions before we move on? Okay, I hope we are together so far. Are we?
Yeah.
Yes.
You don't sound very convincing. Hassan Mohammed, are you there? Hassan Mohammed? Hassan Mohammed? You're not in class, eh? So why do you not have a microphone? Why are you talking to me through the chat box? Okay. One of these days, I will give you what do you call it? A quiz. Those of you who are fond of not attending class, you'll find the quiz done in the first 15 minutes of the class. Right, so I move on to the next topic we want to cover. So why the transport layer? Of course, by now you already know reasons why we need the transport layer, because the IP layer is not sufficient. But there are some things we want to say about the transport layer which are important. Okay, so this is the outline of what we are going to look at. First of all, we are going to answer why do we need a transport layer? What are the requirements of the transport layer? And how the transport layer depends on the network layer functions. The transport layer services, notice again, they are connectionless and connection oriented. So we can have connectionless and connection oriented on layer 2, layer 3, layer 4. I think we already did connectionless and connection oriented in layer 2. We already talked about that. We have also talked about connectionless and connection oriented in layer 3. I think we discussed that in the morning when we talked about ones which are connection oriented and ones which are connectionless. Those are at the transport layer. Yeah. Not at the transport layer. The connection oriented ones are at the data link layer. Because remember that wide area networks only have 2 layers. So if they're using connection oriented, we are talking about connection oriented at layer 2. When you're talking about wide area networks and we're talking about connectionless transport service, we are talking about layer 3. But we can also have layer 3 connection oriented, which we have said is very difficult to implement and it is not necessary. And now again, at transport layer, we are talking about connectionless and connection oriented. So this terminology and this concept is a very important thing as you move on. Then, of course, differences between transport and network service, and we'll talk about those topics. So, why do we need the transport layer? First of all, you need to remember that the IP layer provides a host-to-host packet delivery service. What does that mean? It means that it takes data from computer A and delivers it to computer B. That is what you call host-to-host packet delivery. That is the job of the network layer. From machine A to machine B, through many intermediate nodes, which are typically routers, which use routing tables. That is the job of the IP layer. But now we have already said that this layer does not provide the kind of service that application needs. This host-to-host packet delivery, and I'm on the last bullet, this host-to-host packet delivery service is not ideal for programs. And remember that a program that is running is typically called a process. So the process running on computer A is the one that will initiate the communication by trying to send either some video file or some audio file or some data. It will be trying to send that data to another program running on another computer B. So it will be a process-to-process communication. And we have said that this host-to-host packet delivery service, which is being used by the programs to communicate, is not ideal because it loses packets, it delivers them to the destination in out of sequence, those kind of things. So we've said it is not good. This IP layer is not good for process-to-process communication. And let me try and draw what I'm trying to say. If this is your computer, and in this computer, there are all those layers of network software, then your program is running on this computer, and it is trying to talk with another program running on another computer. And within that computer, within the operating system, there are those network layers. So it is trying to communicate with this program that is running on that computer. So it's a process-to-process communication. But that communication takes place through those layers. We said how it happens. And then it is forwarded to the other computer. And then when it arrives here, it is given to this program. Okay, then the program displays it for the user. So now, the job of the transport layer is to try and turn that unreliable service provided by the network layer into a reliable service that can be used by programs. That is the job, simply the job of the transport layer. If the transport layer is not there, the communication between those two programs will be unreliable. But it is the job of the transport layer to take that unreliable service being provided underneath and make it somehow reliable, so that programs can be sure that when they send their data, it will arrive reliably. Now, the important thing here to mention is this transport layer connection a physical connection? And the answer is no, it is not a physical connection. There is no dedicated circuit devoted to those two applications. Now, what do I mean by that? If that service has to be reliable, remember we said anything connection oriented is reliable. So assume there's a transport layer here that is providing a reliable service between these two programs. Assume there's a transport layer here and there's another transport layer here. And then the application is running on top of the transport layer. Then one of the things you must be sure about is that this transport layer will provide a connection. It will provide a connection for this application. So when these two applications need to talk, they will create a connection. Through the transport layer, they will tell the transport layer, create a connection for me between my program and the other program, so that I can use that reliable connection to communicate with program B. That is what the application will do, because you've said the transport layer provides a reliable service. So it will have to first go through the process of creating a connection, sending data reliably, and terminating that connection. So the transport layer must provide those three phases for the application, so that the application can be sure that what it is sending is being received reliably. But now what we are asking, that connection that the transport layer provides, is it a physical connection? And the answer is no. It is not a physical connection. Now, how is it then a connection and it's not a physical connection? Now, let me try and just try and use, I can get a Jamboard, I'll be able to explain it better. So let me create a Jamboard here and try to explain what kind of a connection is it that we are creating between those two applications there. Okay. So I hope you can see my Jamboard. Can you?
Yeah.
Yes.
Okay. So one thing we need to remind ourselves is about is this. If this is the computer that is communicating, and it is connected to some nodes here. So let me create some intermediate nodes there. So it sends its data to the intermediate node, passes to another intermediate node, and so on until it gets to its destination. So then this would be our computer B. This would be our computer B, which is communicating with computer A. Now, what kind of software is running on these nodes? On the sending machine, there are several layers. There are 4 layers. There is the physical layer, there is the data link layer, there is the IP layer, and there is the transport layer. That's on the end machine. On this other machine, the same thing. There is a physical layer, there is a data link layer, there is network layer, and then there is transport layer. And then the application is running on top of that and not on the IP layer. So the application is running there. Now, somebody tell me, which layers are in these intermediate nodes? And why would you say so? Which layers are they running? Yes?
They're running the first 3 layers.
They're running the first 3 layers, which are?
The physical, data link, and network.
Exactly. Because these are routers. Remember? These, if you are talking about the internet, they are routers. So here we are talking about the internet. If they were wide area network intermediate nodes, they'll be running only layer 1 and layer 2. So it means, therefore, that on these routers here, we have on each router, we have the physical layer, the data link layer, and the network layer. And that's why we said when a packet arrives at that router, it goes up to the upper layer, which is the network layer. And there, then it is dismantled, the destination address is ANDed with another one and so on, and then it is forwarded. So all these intermediate layers, intermediate nodes, they are running only layer 1, 2, and 3. So where is the transport layer running? Only on the end nodes. So coming back to the question, when an application here, this application 1, is trying to talk to application A, is trying to talk to application B, and it tells the transport layer, create for me a connection to that program because I want to talk to it. Where is that connection? Remember, it's a transport connection. It is not a network connection. So how does it look like? First of all, if the network layer was connection oriented, if the network layer was connection oriented, then as we saw, you can create a connection and a path will be chosen through the network, even if it's not dedicated, but that will form the network connection. And I said if it is connection oriented. But remember, the internet, we have already said, is connectionless. There are no connections on the internet at the network layer. They are just simply not there. So when you create a transport connection, what exactly does that mean? It is not a physical connection you can find anywhere on the internet. It is not there. It is simply a kind of a virtual connection that is only known by these two programs, A and B. They're the only ones that know that connection exists. It is not recorded on any of those routers anywhere that there's a connection between computer A and computer B. It's a virtual thing. So please remember that. A transport connection is very different from a network connection. And it's very different from a data link connection. Because a data link connection, remember, a data link connection is between two nodes. Am I not able to reduce this thing? So a data link connection will be only between two nodes. Only. That will be a data link connection because data link operates between two nodes. A network connection will be between several nodes. And a transport connection is between the two programs that are creating the connection. And there's no reference to it anywhere on the internet. But if the internet were using connection oriented, then that transport connection would be mapped onto the lower level network connection. In other words, the transport connection would use this network connection to move data between program A and program B. So when we talk about transport connection, I want you to just remember what it is. What exactly is it? Right, so we go back to why we need the transport layer and the connections that it forms. So the transport layer connection is not a physical connection. There is no dedicated circuit devoted to transmitting information between the user and the computer. I don't even know whether that is a correct statement, between the two users. So the transport layer protocol is sometimes called an end-to-end protocol. Why end-to-end? Because the applications are end application programs. If you remember the diagram I've just drawn, the application is running on one end computer and is talking to another application on the other end. So the transport layer protocol, which creates that connection, is an end-to-end protocol. It operates on the end machines, as I said. It is only known by those two end machines because they are the only ones that have the transport layer. These devices in between don't have the transport layer, so they don't know about the transport connection. So it is mostly an okay, so this is just the diagram I drew. It's in a different format in that you have the network layer here, you have the transport layer, and you have the application running on top. So the application is running at the application layer on top of the transport layer. That's the whole idea of this diagram. But there are other things I will come back to mention later. Okay. So what have we said? Why do we need the transport layer? Why do we need it? Because the host-to-host delivery packet is insufficient to support the process-to-process communication that is required. Process-to-process communication does not require data to get lost or to be reordered or things like that. Programs do not want that kind of thing. Okay, they require a connection between them that will be reliable. That's what they want. Reliable communication through a connection made between the source computer, source process, and destination process. That's really what we have said in that section. So, what are the requirements of the transport layer? Remember, the application runs on the transport layer. So the application programs that use the transport layer services have certain requirements. Notice the applications that run on top of the transport layer have certain requirements. One, guaranteed message delivery. We've talked about that. Any program that's running wants to be sure that the message is delivered. And they want to be sure that the messages are delivered in the same order they were sent. And they want to be sure that the messages that are delivered, only one copy of the message will be sent or given to the receiver, not multiple copies. Remember, we said that at the network layer, you can have multiple copies of the same message. So if the network layer receives multiple copies of the same message, it will just pass all those copies to the application. But we want only one copy of the message to reach the application, and that is the work of the transport layer. So applications require that when they send a message, even if there's duplication in the network, only one will be received. And this last point is very important. Applications want to be able to send arbitrarily large messages, like video files, any large file. You don't want to be limited. That's really what that statement is saying. No application wants to be limited to say you can only send a file this size. Beyond this size, you're not allowed to send. No. Whatever file size I want to send, whatever information I want to get, however large it is, I should be allowed to send it or receive it. Those are the things that applications require, and which the network layer is not able to provide. Applications also require synchronization between the sender and receiver. We shall come across synchronization much later, but sometimes the applications just need to synchronize. Who talks first and who talks next, so that there is no confusion about who is supposed to be doing what. That kind of synchronization is required. For example, in the client-server model, who usually talks first? It is the client. The server will never come to the application and say to the client and say, what do you want? It is you to tell the web server which page you want. The web server will never come to you and say, please tell me which page you want. So in such a case, there needs to be that synchronization. Who asks for what? The server is simply there to respond. If you ask, I will respond. If you don't ask, I will keep quiet. Another requirement is that it should allow the receiver to apply flow control to the sender. If the receiver is overwhelmed, they should be able to tell the sender, look, it's too much, please hold on, or send at a lower rate. Again, that is not provided by the IP layer. The IP layer does not provide flow control, but applications need it. If you're sending data and it's being displayed, let's even assume it is a video conference like this. You are sending data and the receiver can't, display it at the rate at which it is being sent. It should be enough to say, look, please slow down, so that some of the video components don't get lost. And lastly, this last point here is also very important. Computers want to be able to support multiple application processes on each host, something that the IP layer does not take into account. Now, right now, I don't know on each of your computers how many programs you are running, but I presume you are running several programs at the same time. As for me, you have seen that I'm running the Google Meet, I'm running the whiteboard, you know, and I'm running these other programs like my Google Sheets and so on. So users on the end computers usually want the flexibility to run as many applications as they wish to run. Now, why is that point important? Why is that point even important? Now, look at it this way. Assume this is your network and data is being moved from computer A to computer B. Okay? Now, the application, the user is running 3 different applications. Okay, and assume there is no transport layer. So at the moment, we don't have transport layer. We are using the IP layer. Okay, so this application will send its data, and let's assume they are all clients, and they are going to respective servers. Maybe one is an email server, one is a mail server, and one is maybe a web server, something like that. So these are client programs. So they are all running and sending their data through this IP layer on that machine. The IP layer takes the data, sends it across to this machine, and they arrive, all of them. Now, the IP layer has no capability to know which of these programs should receive which message. If you go to an IP message and you look at the header, I think we did that before we finished the previous class. The IP header has nowhere where it says this packet is to be submitted to this application. It has no notion of which application should receive it. It simply passes it upwards. It simply passes it upward, normally to the transport layer. So if you were to leave this kind of thing to the IP layer, data would perhaps maybe only go to one application. The IP layer has no way to distinguish this packet is for the web server, this packet is for the email server. It doesn't have that ability. It simply takes all the information and deposits it on the destination machine, and there ends the job of the IP layer. Who then knows that this message is meant for the web server and this other one is meant for the email server? Who will do that? Because you said users like to run many applications at the same time. That job can only be done by another layer, and that is the transport layer. So here we have basically looked at what do the applications require? What do they require? And therefore, if that is what they require, that is what they want the transport layer to provide. So all these things we have talked about, they are the things that applications require from the transport layer so that they can, those applications can run correctly, or so that the users who run those applications will be happy. So ultimately, all these things will have to be provided by the transport layer, because we have seen that the network layer does not provide them. So is there any one of these things I have mentioned that you as a user, you don't think an application requires? Just look at them again. Since you have been writing applications for quite a while, is there any of them that you think is an unnecessary requirement? Guaranteed message delivery, messages to be delivered in the same order, only one copy of each message to be sent, sending arbitrarily large messages, synchronization, that one you may not know because it's not normally done by users. Okay, sometimes you have to do it here, but you may not be familiar with it now, maybe because you have not written client server programs, I don't know. Allow the receiver to apply flow control to the sender. Yeah, that one you may be able to appreciate it, and supporting multiple application processes. Any one of them, anybody challenges that? I hope not. Right. So if the transport layer is to provide those services, remember it has to depend on the network layer to provide the services that it requires, that are required. But we have already said that the network service does not help it to provide, because the network service drops messages, does the extreme opposite of what it is required to do. It drops messages, it reorders them, it delivers duplicates, it limits message sizes to some finite size. Messages can be delivered after an arbitrarily long delay and so on. So what is left to be done? What can the transport layer do? Because it's relying on a service that doesn't provide what it needs. So it means that within the transport layer, you must provide some algorithms. You must provide some software or some techniques that turn what the network layer is doing into what the application requires. That's really just what it means. So the transport layer must have certain algorithms by which, if a network layer drops a message, the transport layer should be able to retrieve that message again, or have the message retransmitted. If the network layer reorders the messages, then it must find a way of ordering them and passing them to application in the correct order. If the network layer delivers duplicate copies of a message, then the transport layer must be able to determine which is a duplicate and drop it. So ideally, the transport layer must have certain algorithms by which it turns around what the network layer does to make the application believe that that didn't happen. So the different transport protocols apply different algorithms to achieve their end. So what are the functions of the transport service? One is to provide a reliable service, more reliable than the network service. So where the network is dropping messages, it will not drop. Where the network is reordering messages, it will not reorder. So it provides a more reliable service than the network service. I hope that is clear. Now, this might not be clear, but it is important. It provides a standard transport interface that works on a variety of networks and hides the differences in subnet interfaces. Remember, we said that there are many different kinds of networks around the world. But the idea here is that when you are programming on the network, you really don't want to know which network you are programming for. You don't really want to take that into account. You want that complexity of which network is which to be hidden from you, so that you're provided by a standard transport interface that you can use to program regardless of which network you're programming, or even regardless of which operating system you are using. So that ideally you should be able to program on any operating system, on running any network protocols, and your programs will communicate, even if they're on different computers. So it is the job of the transport layer to provide that standard interface for programming and hide from the users any network details, any complexities of the network. So the programmer can write code without having to worry about interfacing with a variety of networks. So I can take my program, which I wrote on my computer when I was running on perhaps an Ethernet network, Maybe I have moved to another institution and they are running a different type of network. If I had written that program 1 year ago and I have maybe transferred or moved to a different place, I should be able to take that program and run it on the computers on that other institution that I've gone to without making no change whatsoever. Why? Because the API is the same for all computers. That is the idea. And I hope it makes sense. So any questions? I don't know whether we are still together. Any questions on what the transport layer does?
Um, this is just to recap. It's true to say that a characteristic of the transport layer is that it's interoperable.
Sure.
Okay. Thanks.
Sure. Yeah, that term, if that makes more sense, if that is something you can resonate with, yeah. It provides interoperability between different networks. Edith?
Yes, I wanted to ask about the dependence on the network layer, but also, like, how does it turn around what the network layer does already?
How does it?
Turn around what the network layer does.
Yeah, I said it does that using certain algorithms. And remember, in this section, we are looking at the transport layer. So we will come across those algorithms or what it is capable of doing to turn around what the network layer does so that the application does not know. So maybe it's a kind of a premature question. I don't know if I understood your question. I think it's a kind of a premature question because there's a whole section on what the transport layer actually does. We know what it needs to provide to the application, but we haven't talked about how does it do it. We have only said it needs to turn around what the network layer does so that the application doesn't know. So the application sees messages are not getting lost, they are not reordered. None of that thing is happening, but the application doesn't know how the transport layer is doing it. So the objective of looking at the transport layer is to understand how does it do all those things we are talking about. Am I answering your question?
Yes. So it's something that we'll like cover later. In
Pardon?
depth. I'm saying it's something that we'll cover in depth later.
Yes. If you look into your classroom, those notes are already there. There's a lot about what the net transport layer is actually supposed to do. And that is what we shall be looking at. Here we are just setting the stage so that we are all in agreement that first we need the transport layer. Why? Because the application needs it. What does the application need from it? We have specified. So now what is left to be done is how does the transport layer actually do that?
Okay.
Yeah. So there's a whole section yet to come. Right. So what are the transport services? So we've said that the application needs all those things. So what kind of services does the transport layer provide? One, it provides a connection-oriented service and also a connectionless service, so that the application that needs a connectionless service will use the connectionless service. The application that needs a connection-oriented service, which we said means reliable, will use the reliable. But not all applications actually want a reliable service. All those things we have said may not apply to all applications. There are some applications that really can do with the connectionless. And remember, connectionless means unreliable. So there are some applications that can do with the unreliable type of service. Which means that in that case, the transport layer doesn't have to do much because already the network layer is unreliable. The application also requires unreliable. So the transport layer doesn't have much to do. But the transport layer may need to add that thing which we talked about, that it should be able to know which application. If the user is running more than one application, it should be able to know this packet I've received is for application 1, and this one is for application 2, because the network layer doesn't do that. So, but in terms of the reliability, it might not have much to do because the application also doesn't require it. Yeah. Right, so let's look at the connectionless service from the application perspective. So assuming an application is using a connectionless service, what exactly does that mean? A connectionless transport service. What does that mean? So in a connectionless transport service, it means that the application can send data, but whichever data it sends, they are not related. They are independent. So if the application has 2 packets to send, packet 1 and 2, they are no longer related. They are just like you write letters and you take them to the post office, and the post office man doesn't need to know that they are related. As long as you put the address on the envelope, it knows this one is going to such and such a place and this other one such and such a place. They are totally independent. There is no need to order them because they are not ordered. Even the user has not ordered them. They are totally independent. So if the user has 10 packets, they are all independent. The transport layer has no need to order them because they are not ordered. They are all independent. Now, let me give you an example. Let's assume you are sending an email. You're sending 10 emails. Is there any need for the transport layer to order those 10 emails? No. They are totally unordered. They are going to different people. So there is no need to order them. So that's what a connectionless service means. It means that the packets are totally independent. So the source process will divide the message, whichever message it's sending, into chunks of data which are accessible to the transport layer and deliver them to the transport layer. So it takes whatever data it needs to send and it breaks it down into chunks and it passes them to the transport layer. And the transport layer treats them each as an independent unit. And there's no relationship between them. There is no need to order them. So all that the transport layer will need to do is to take each of them, encapsulate it with the appropriate information for that level, because at each level you encapsulate and you add a header. So all that the transport layer has to do is to put a header on each one of those chunks and then pass those chunks to the lower layer. So since they are not dependent on each other, it means that when they arrive, they can be delivered out of order. There's no need to order them, as we've said. And some of them can even get lost because it's a connectionless service. They are not only independent, but they can also, it's not a reliable delivery. So some of them could get lost and the transport layer won't do anything to recover them. And the 2 transport layers do not need to coordinate with each other. Like, for example, there is no need to tell the other transport layer that I have received. There's no coordination between them. So basically that defines for you the connectionless service that the transport layer uses. So if an application is using this service, it takes whatever data it wants to send, sends them, and the transport layer assumes they are not related. It makes the best effort to get them to their destination, but even if they don't get there, there's no guarantee. There was never a guarantee that they will get there. And there was never a guarantee they will arrive in any order. So think about an application that may want to do that. As I said, there are some applications that really don't mind, but most applications will require this type of connection-oriented. So how does the connection-oriented works? The connection-oriented assumes that the application that is sending wants a reliable service. They want to be sure that the data arrives at the destination it is ordered, none of the messages gets lost, those type of things we've talked about. So what does the application do? The application establishes a connection with the other application, the other process on the other side. So I should not be saying application. Most of the time I should say process, because an application, when it begins to run, it is a process. So really, if I use application, just know I mean a process. So if it's a client-server application, then the client process will first establish a connection with the server process. After the connection is established, then the client process will send data through that connection. And after the data is exchanged, then the client will terminate the connection. And there needs to be coordination between those two, so that if any packet is lost, the server will ask the client to retransmit. So there is that coordination to ensure reliability. And now notice, this is what I had said earlier, when I had said that the transport connection is a virtual connection and it only exists on the two-end computers. So if it only exists on the two-end computers, only those two-end computers need to coordinate their efforts. So their coordination can either happen on a connection-oriented network service or a connectionless network service. It doesn't matter. Either way, they'll have to coordinate. But the connection is only between two hosts, the sender and the receiver. But it uses, of course, the intermediate nodes, because obviously they'll have to communicate through the intermediate nodes. But the intermediate nodes may not know that there's coordination taking place. So the coordination involves flow control, error control, congestion control. I don't think we've ever done congestion control, but I heard one of you talking about congestion control. It's a totally different topic. Very important as well. I think because of time, we might not cover it, but it's an important topic. So the two ends will do flow control, error control, congestion control, everything required to make that communication reliable. And even though it is not said here, I don't know if I've said it anywhere, but remember we said that the data that is sent through the connectionless service, they are totally unrelated. In this service, all the data is related. They will arrive at the destination in the order in which they were sent. They will be given to the application in the order in which they were sent. Maybe that's a better way to put it. Because if you're using a connectionless network service, they may arrive out of order. But it is the job of the transport service to put them together and to give them to the application in the order in which the sender sent them, so that the application has no idea of anything that happened in between. So even though I have not written here, you need to add that in this case, the data that is sent will be sent in a certain order and it will be received by the application in the same order. Okay, so I hope that differentiates for you the transport layer services, because all those things we said about unreliability, they are captured in that definition. Once you create a connection, you are sure all these things will be taken care of. The reordering and so on, all those things will be taken care of by simply creating that connection. So let's try and distinguish between the transport service and the network service. The transport service is intended to model how processes communicate. It is closer to the way programs want to talk to each other, unlike the network service. So that's why it assumes a reliable connection. It is closer to the way most people want to write programs. The network service is intended to model the network. It is closer to how the network works. Than applications. So it was written for networks, it was not written for applications. The transport service was specifically developed to be close to how programmers want to program. So the transport service is intended for programmers, and that interface for programming is intended for programmers, and it is supposed to be convenient and to have very little information about networks, so that you program without knowing too much about the network or the internal workings of the network. The network service, however, is intended to be used by the transport service, so that the transport service can be able to say, because the network service is for moving data from computer A to computer B. So the transport service should be able to use it in that way and say, take this data and send it to computer B. So the network service was intended for the transport service to use, and it's supposed to mirror how the network works, which is just simply take this data from this computer and move it to computer B. Well, I hope that distinguishes for you how the two are different. One is intended for the user or the programmer. One is intended for another service, which is supposed to know about networks. It's supposed to know about IP addresses and things like that. All right. I think I'm at the end, really. So let me just briefly say something, although we'll come to this later on. It will make sense when we move to what I think Edith was asking. How does it do that? So, in a nutshell, so we've talked about the transport layer transforming things so that the application has no idea that anything bad could be happening underneath. But when the transport layer protocols are written, or when the algorithms you are talking about are written, they have to take into account the operating environment of the transport layer. In other words, they have to take into account what is the environment under which the transport layer is working. And the transport layer is basically working in this environment. Assume this is the internet. Okay, we say data comes from one computer to another one. But here in between, there are so many intermediate nodes it must pass through, and so many things that could go wrong, like those packets being lost. So that transport layer, when it is writing those algorithms for transforming the network into something that applications appreciate, it must take that into account. In this environment, so many things can go wrong, so many. Much more than the connection that is created between two nodes. Remember, we say there's connection at data link layer, at network layer, at transport layer. At the transport layer, your data link layer, there's only two nodes that are connected. This link is either working or it's not working. The speed of this link, you know it. If it is 10 megabits per second, you know. So you know how fast data will travel. Okay, so it's easier to create a connection when you have only two nodes. Very few things can go wrong and you don't know. But here, so many things could happen and you didn't know. For example, you send data, it's working correctly, it is received there, it is passed, but somewhere along the way, something happens. Now the sender doesn't know. Do they know that this link went down? Do they know that a router is not working? They have no idea. So many things could be wrong or could happen inside here and the sender would not. So even the question of retransmission, do you retransmit after timeout, as the way we had looked at earlier? And what is the timeout anyway? Because remember, we said here, things can take arbitrarily long. So even if you're setting a timeout, how do you set it? And you don't know the time it will take for the data to move to the destination. You don't know. But on this link, you know exactly how long it will take. So that if you are setting up a timeout, you know how long the timeout should be. So you know how to do reliability on this, in this system. But don't assume that all the things that happen in this system can just be mapped onto another system and it will work. It will use the same principles of retransmission and all those things, but they'll be very different because the operating environment is very different. That's all I need to say. So when we start looking at the different ways in which it transforms the network service, you will find that this operating environment will have a lot of influence on how those protocols work. Even the ones you already know, like sliding window and so on. The sliding window might be so different. The timeout mechanism will be so different. Why? Because they are two different environments. One is an end-to-end protocol. One is a node-to-node. Two nodes that are directly connected. So I think from the next class, we will now start looking at exactly what does the transport layer do to provide that service which the application wants. And that brings me to the end. And again, I want you to look at these questions. Maybe we'll discuss them next time, but look at all those questions. And this is the main question you need to look at, which is a summary of what I've just really been trying to say. What makes the transport service better suited compared to the network service for running network application? What is it that the transport layer service provides that the network layer does not provide? Why is it a better environment for running applications? That's a question you need to be able to answer. Then, of course, you look at the others and you try to answer them. If you can answer them, you've understood what you are talking about. And so that brings me to the end of this session. If you have any questions, please ask. Now, I promised to provide a program for you to start writing. I haven't done so. Apologies. I think I will do it before the end of today. So please look out for it. It will be in your classroom. I don't know if I've received any group a list of groups. If I haven't, please can the class reps provide me with members of groups of 5, as I said, because those applications where they are group applications, you write them in groups of 5. So let me have them by tomorrow morning. All of you form 5 groups of 5, not more than 5. I said if there's any group that will have less than 5, it will be one group. But I would like you to keep the group 1 and group 2 separate, and you create groups of 5 from that. So thank you very much, and we'll see you in the next class. Now, the next class will not be Friday because Friday is a holiday. It will not be Monday because Monday is a holiday, so we are already missing 2 classes. I requested that we make up for those classes, and there was a suggestion that we could make up for those 2 classes on Monday morning as we did today, so that on 2 consecutive Mondays after the Easter holiday, we will have a class morning. Then from there, of course, we can continue as usual. Our classes will be Monday and Friday, but 2 Mondays after the Easter, we will have that morning 9 o'clock class to make up for the Friday class and the Monday class we are missing this week. So I'll make sure the program is out so that over Easter, as you celebrate, you think about writing those programs. Any question? All right. Have a good day and have a good Easter.
You too.